Assalamualaikum and very good morning. So for today's lecture, we will continue with chain transfer to monomer. Okay, chain transfer is occur when a chain stop grow, but polymerization not stop because new radical is generated. Okay, so for chain transfer to monomer, it involves the transfer of hydrogen either from the monomer. Okay, hydrogen come from this monomer, which is hydrogen yang ini, to the radical reaction. Ataupun dia boleh jadi transfer of hydrogen from the radical active site to the monomer. Okay, and then the growth of the polymer radical is terminated by leaving the new radical. Okay, yang ni dia terminated, tapi dia akan produce one new radical. So chain transfer to monomer involve hydrogen abstraction. In hydrogen abstraction, we can see that the active site at the front of this active site chain, dia transfer ke sini, dia akan pindah ke sini. So structure ni dia hilang dia punya H dia, sebab satu H kat sini dia dah transfer ke sini. So we call it as the hydrogen abstraction. In hydrogen abstraction, it is the abstraction of hydrogen, okay, to the other structure. For hydrogen donation, we can see that the hydrogen here, hydrogen in this structure, the double bond in this structure, it transfer the hydrogen to adjacent bond. Dia transfer hydrogen ke sini. So dia jadi CH3, and then double bond dia transfer ke sini. Okay, this is the example of chain transfer to monomer. So it enable of starting the growth of new or capable only of combination with another allyl radical. Other possible termination. Reaction between a growing chain and a radical which has not reacted with any monomer molecule. It occurs when high concentration of initiator are used. The concentration of monomer is depleted and the viscosity of the system is increased. So the growing chain lose their ability to diffuse around, and thus it is more difficult for the two chains to react each other. So the other possible termination involve the general type concentration of initiator, monomer, and also the viscosity. Okay, this is the overall reaction from initiation. For example, BPO dengan polystyrene. Yang daripada awal-awal reaction yang kita belajar tadi. Minggu lepas. Bukan minggu lepas, hari Selasa. Okay, so awak boleh try practice banyak kali. So untuk yang ni awak tak perlu tulis, awak perlu hanya tahu untuk tulis structure yang ini saja. You are very lucky because you don't need to remember the structure because of the current situation. Okay, so you can always refer to the notes how the structure is, especially for initiator and basic polymer structure. Okay, so this is the termination by disproportionation, termination by chain transfer. Alright, for today's lecture, we are going to cover about polymerization kinetics. So it involves many formula. So all you need to do is you have to know where to apply this formula. Okay, for initiation rate, it is given with symbol R, I, the small capital letter of I here. So For Ri is the rate of initiation. Okay. Okay, by assuming that the rate for initiation is more faster than the rate of the dissociation. Okay, and accounting for the fact that two radicals are formed during every initiator decomposition. So the rate of the initiation Ri is represented by differentiation of the molecular ataupun the concentration of monomer with time. Okay, F is the initiator efficiency and concentration of initiator. This is the concentration of initiator. So M naught is the total concentration of chain radical. And when we will going to use this equation, okay, I will show the example of the question so that you can get a clear view. So the question also will ask what is the rate for termination. So rate for termination is given by Ri equal to Rt. So rate of termination, you can just take the value of the rate of initiation. Okay, steady state assumption is given by rate of initiation equal to rate of termination. And then you need to calculate total concentration of chain radicals by using this formula FKD I over KT. So the value for KD will be given, also the value for KT. So we square root this equation, then we get the total concentration of chain radical. So this is the steady state assumption. For propagation rate is represented by Rp. So we use this equation, okay, to calculate the propagation rate. So since the rate of propagation Rp is essentially the rate of polymerization, so the rate of polymerization is proportional to the rate of I, which is molar concentration of initiator with a square root here, and proportional to the rate of concentration ataupun molarity ataupun concentration of the chain. Okay. This is the average kinetic chain length. The question also sometimes asks you what is the kinetic chain length. It is represented by this symbol. So you can use this equation either Rp over Ri or Rp over Rt. So it can be either kinetic chain length with disproportionation or by coupling. So if you get the value for kinetic chain length here, if the question wants you to give the kinetic chain length by termination by coupling or combination, you just have to times with 2. Okay, we will see the example at another slide. Okay, for average free radical lifetime, we can use this equation. Okay, kinetic chain length. Okay, this is the kinetic chain length, and kita boleh pakai equation yang ini, Rp over Ri ataupun Rp over Rt, dan juga sama juga dengan yang ni. Kalau soalan tak tanya RP, so awak kena kira balik yang ni lah, equation dia. So ambil yang ni lah, senang sikit guna equation yang ini. For DP, degree of polymerization, is given by dP, also symbol as xn, equal to V. If termination by disproportionation. Okay. For dP by combination, you have to multiply with 2. Alright, let's do the exercise from the final exam question December 2015. Monomer is polymerized by free radical mechanism in solution. So the initial monomer and initiator concentration were 1 molar and 0.0001 molar respectively. The initiator efficiency F is 0.75 at the polymerization temperature at 60 degrees C. And the reaction was completely reacted about 15 minutes. In the rate constant at the polymerization temperature are as follows. So the value of Kd, which is rate constant for Kd is rate constant for dissociation, Kt is rate constant for termination, and Kp is rate constant for propagation. So you have to calculate Ri, steady state free radical concentration, Rp, chain length, degree of polymerization, Rt, and average free radical lifetime. Okay, first you need to list down all the information given by the question. So given that the initial concentration of the initiator is 0.001 molar, okay, initial concentration of monomer given by M naught is 1 molar, initiator efficiency is 0.75 times is 15 minutes, you need to convert to second, so we get 900 seconds. Okay, for rate of initiation Ri, use this formula, but then you need to find the initiator concentration. Given is the initial concentration of initiator. So use this formula, I naught exponential of negative kdt. So please calculate or use your calculator wisely. Otherwise, you cannot get this value. Okay. So make sure at the end of the calculation for Ri, you will get this value. Alright, for steady state free radical concentration, we use this formula. So the symbol for steady state is either I M radical or M with radical. Okay, it is the same symbols. And then the answer is you will get 4.17. So try calculate by your own whether you can get this value or not. Okay, so for rate of propagation, you can use this type of equation, but you need to find M first. Okay, in this calculation, you have found that this I is used to find initial concentration, not initial initiator concentration, right? By using this formula. So to find monomer concentration, you need to use these types of formula. So M naught is 1, okay, M initial. So you will get 0.9994, and then this value you will place in the equation here. So you will get 6.76. Okay, for V, if the question did not ask you to terminate either by combination or disproportionation, so you have to give this both two value, right? This is for